we're going to find y prime for this implicit function, so we'll have to use implicit differentiation. I notice in here I've got a product, and a log, so there's quite a few rules we're going to have to use. So let's go. So to start, let's take a look at this one here. So it's going to be the derivative of the first. I'm going to get 15x squared times the second. So how about we start with 15x squared times the second plus the first, 5x cubed times the derivative of the second. Now we've got y squared, but y, remember, is an implied function of x. So we got the outside, and the inside. So we're going to get times 2y and then y prime, right? The derivative of the outside times the derivative of the inside. Plus, okay? So plus. Now this is a log function. We know how to differentiate log functions. It's 1 over the argument times the derivative of the argument. So 1 over the argument is going to be 1 over xy squared times the derivative of the argument. Now the argument's a product, so we'll use the product rule. So I'll use parentheses here. Now I've got a first factor and a second. The derivative of the first is just 1 times the second. So 1 times the second, derivative of the first times the second, plus the first, x times the derivative of the second. Now remember, y is a function of x, so we'll use implicit rule here. So 2y, derivative of the outside, times the derivative of the inside, equals, now the derivative of 5, that's just a constant, that's 0. So I've got the calculus part done. Now we need to fix it up with some algebra here. So let's just start from here and go through it. So we're going to get, how about 15x squared y squared plus, now here looks like 10 x cubed y prime plus, now this is going to be 1 over xy squared times, what do we got inside here? Well, 1 times y squared is just the y squared plus, now how about if I write this as, okay, x 2y, I'll write it as 2xy y prime equals 0. Now I think I'm going to distribute this. I'm going to distribute this and see where we end up with. So we'll have our 15xy squared plus 10 x cubed y prime plus, now right here, the y, okay, I'll write it all. 1 over xy squared times y squared, so those y squareds will cancel, plus, and then 1 over xy squared times 2xy y prime, that's all equal to 0. So, start it again here. 15x y squared plus 10 x cubed y prime plus, now what happens here? What happens in this one? The y squareds are going to cancel, right? Those y squareds cancel, and we just get 1 over x plus, now what happens over here? What happens over here? Well, it looks like this x will cancel with that one. This y here will cancel with one of those, and we're left with, well, what are we left with? That 2, the y prime, and a y down here. So it looks like we're left with a 2, let me do that in white. We're left with a 2 over y, and then that y prime, that's all equal to 0. Now, I've got an equation involving fractions. I'm going to get the LCD, which is x times y, and multiply it all the way through by xy. So my plan here is to multiply by xy. So I'm going to multiply every single term by xy. All the denominators should cancel to the top of the page here. We're going to get, right now from the first one, we're going to get 15 x squared y cubed. So up here, I'll write it, we're going to get 15 x squared y cubed. Then, down here, we're going to get what? We're going to get 10 x to the fourth y squared, right, 10 x to the fourth y squared y prime. So that's going to be plus 10 x squared y to the fourth y prime plus, now in this one, the x's cancel. That x cancels with that one. We're just left with a y. So here we're left with just a y plus, now over here, the y's are going to cancel. That y goes with that y, and I'm left with that. I'm left with this 2, the x, and the y prime. So we'll get 2x y prime equals, and on the right side, 0 times anything is 0. Now let's get these y primes. Here's a y prime, here's a y prime. So let's keep these on the left side and get this term here to the right and this term here to the right. So that's going to give us 10 x squared y to the 4th y prime plus 2x y prime. That's going to be negative 15 x squared y cubed minus y, right? Because I'm subtracting this, so it becomes negative. We're subtracting this, it becomes negative. Let's factor out this y prime. So if we factor out that y prime, I'll do it down here. Y prime, what's left? Well, what's left is going to be 10x squared y to the 4th plus 2x, right? What I'm doing, I'm taking this y prime out. What's left is 10x squared y to the 4th, right here, and then a plus 2x. And that's equal to this negative 15x squared y cubed minus y. Now, we'll divide by this. So we are going to get y prime is equal to, okay, negative 15x squared y cubed minus y over, now I'm making that division, so over 10x squared y to the 4th plus 2x. Now we've got it. We could leave it like this, but I see I can factor a little bit, so I'm going to factor. So in the top, I'm going to write it like this. In the top, what's common to the top? There's a negative in both, so I can take out a negative. And then there's at least a y in each one. So I could actually take out a negative y, and that would leave us with what? 15x squared. There were 3 y's. We removed 1, so there's 2 left. And then minus 1. Or plus 1, right, because I took out a minus. Negative y is a plus 1. Over, now in the bottom, what have we got? We got a 2 and a 10. I can take a 2 out. I've got 2 x's here, 1 here. I can take out a 2x. So if I take out a 2x, I'm left with 5x y to the 4th plus 1. Okay, so the first one is good. This one might be better because it's factored.